Mhm. And what would be like, can you calculate or try how long would such system be able to run? Well, of course, it depends on the power source we give it, right? But mhm. What's possible? Yeah. Yeah, no, I hear you. That's very interesting. That's best, actually. That's the best. I think. I think that's the best. The question is, of course, the big question is what is the minimum or what is the maximum time interval we could afford? That's a big question. But yeah, I need to talk to my student and see. Can you try to give us some numbers so we'll know like what I think DSLR mode seems like the most feasible one. Like because you said that any other option basically gonna be very power hungry, right? Like if we do because even so if I run it every 10 seconds, I'm gonna have it. That's gonna be a significant. That's gonna be a deployment, right? Okay, but that's the camera, eh? And still you have the light source, right? How good it is with the low light? So that's another question. Eh? If we can't use anything other than far red, you see. So everything it needs to be 680 or above the lightning. Otherwise, you disturb the yeah yeah. Because it needs to be a light that they don't see. So it needs to be uh, above 680. I think like 700, 720, 750. These are the kind of wavelengths we want to work with. So the question is basically, uh, yeah, a good LED source. Uh, you know, you can't really see in the water more than 2 meters or so with the, it doesn't really matter, I think, how large the light source is. The water absorbs most of this light at this wavelength, right? But that, mhm, mhm. No doubt about it. Yep, yep, yeah. We actually discussed that. Um, um, yeah, that's always was my thinking that if we put the light source sort of from behind, that should improve the situation a bit. But it's still, I mean, you can't put it very far away because you won't be able to see it. But we can experiment with that. But I think that, so I think it's a question of, um, do you know if the Mobius is even sensitive to this kind of light wavelength? Uh-huh. Mm-hmm. Mm-hmm. Right. Yes. Yes. Right. What about the standard, or there's now, like nowadays there's even this HD security camera that are IR sensitive. Uh, right. I wonder, yeah. Okay. Right. Mm-hmm. IR LEDs, IR LED. It's something you can, A, you can buy, B, you can make, right? We've made those. I mean, I have a light source that is composed of, don't remember. I have it there in rings, like I think I have 8 different wavelengths, and we simply, you know, we wire them and epoxy them, and it's working, right? So, okay, so maybe what do you think is the best way to move forward on that? Like, do you need to do some more research on light sources and or I'll tell you right away. What we want to do is be able to put the camera from above, right? That's the reason I'm not sure. I think the light source would need to be your idea of putting it from behind. It's a bit of a problem probably. What we want to do is basically think about the Sedon, for example, okay? What we want to do is be able to record the fish activity around the Sedon. So ideally we would have the camera looking down with some sort of light source, either from the side or from above. And what she would need is basically, you know, she would ask for a constant recording, if she could, or anything that would record whenever a movement is, something is moving in there, right? Like whenever a fish goes into the frame of view, we want to know that. That's basically our question, right? When do we have fish act, you know, behaving on the bottom, right? Like, especially anything that has to do with sedimentary suspension. It's something we would need to do. That's where she is. That's where she at. The system, we have a system that is working at 600 meters at the bottom of what they call here a dip. It's not very deep, but it's a 600-meter deep sediment trap mooring, and we have a bottom sediment trap that currently it's collecting. You know, it's sort of a stupid sediment trap. The only difference is that that sediment trap is, when we deploy the mooring, it is closed, and then we come a day later and we use acoustic release system to open the bottom trap. Where we want to go is to replace that bottom trap with a Sedon, right? What we want to know is how much of fish activity and when we have a fish activity next to that trap, basically, right? So these things are deployed and redeployed every month. So this is not feasible. Yeah, you're not gonna. I don't see how we are able to run a camera for months, but you know, if we can run it for a couple of days, and if we have a Sedon down there,